Howdy YouTube, Foley here with a Unity tutorial on how to make a tileable material and shader graph based on world position. Now what this does is it allows us to have a wall and a floor that can seamlessly tile based on the mesh's geometry. It doesn't matter. So basically you won't get stretching textures on your normal faces. So what I can do with this is duplicate this object and quickly block out a level with almost no effort. Of course, you'd want to align your geometry better, but this is just for showcase. Anyway, so this can be very handy for floors and walls and other basic geometric shapes like cubes, even capsules, or not capsules, but cylinders it works on. Anyway, let's go ahead and get started. But before we get started, I want to give a quick shout out to Windcrosser and Show off of the Unity forums because they wrote the original shader code for this that I based this also off of. Basically, all I did was translate it into shader graph and add a slight amount of modifications for the walls. Anyway, let's go ahead. It doesn't matter if you are in a new scene or a new project or if you open an existing project, because all we are going to do is create a new shader and a new material. So let's go ahead and create a new cube so that way we can see our shader in progress as we work on it. Once we have our cube, let's go ahead and set it to the world origin and create a new shader. I'm going to create just a PBR graph, but the process should be almost the exact same for a HDRP lit graph shader. So PBR graph, let's name it something like Tileable, and we will create a new material. Name this material Tileable. Then, of course, apply shader we just made. After that, let's apply the material to our object. Now, let's open up the shader. Okay, so we have a blank shader here. Of course, our cube's going to be white. First thing we'll do is add a couple of textures. We'll add one texture for the top. That's actually going to cover the bottom as well. And we'll add another texture for the sides. Then we will add just a vector 1 for our scale. Alrighty, let's first grab our world position by adding a position node here. Then instead of world for the space, we actually want the absolute world. Otherwise, this is going to calculate based on the camera position within the world, which can lead to some neat effects, but not exactly what we're after. All right, so we have our world position, our absolute world position. What we need to do is we're going to first set up our top texture. That way we will get the top texture applied to our mesh. So to get our top coordinates, we need to split out the world position and grab the X and Z channels because they are the two horizontal axes. So our X is red and our Z is blue. If we go back to the shader, we need to grab our red, create a new vector 2, and also plug our blue into it. Then we can multiply it by our scale. And then we need to sample our top texture. And then the output from this multiply will go into the UV for this texture. Once you've done that, you can output the RGBA into our shader albedo. After that's done, hit save. Go ahead and test it out. Go back to our scene. We have our cube selected, and then over here in our tileable material, we can add any texture that we want. I already have two textures that I've been using. This one is just a 64 by 64 repeating sprite tile. So I'm going to plug that into the top texture. Set our scale to 1. And there we have it. We have our top texture. Let's make sure that it is repeating based on the world. Yep. Stretch it out. Perfect. Go ahead and set that little cube. So another thing you might want to do is set a default value to that scale. Set that default to 1. And what that scale is going to allow us to do is simply make the textures smaller or bigger. So a bit bigger. Then we can change the scale. Get very small or very big. Of course, we copy and paste this. It reflects those changes to any other mesh that has this material applied to it. All right, let's reset that. Let's head back to our shader, and let's just set our smoothness to 1. I mean 0, so that way it's not shiny as it was a second ago. All right. Next thing we need to do is check to see if the object's normal that we're applying this texture to is facing up, left, right, down, etc. So that way we know if we want to apply the top texture to it or the side texture to it. So what we're going to do is add right here, we're going to unplug this and add a branch, and we'll set that to the false. We have our branch here. Basically what that is a true or false statement, and we will get to what that statement is in just a second. So let's go ahead and plug this output into our shader again. Our checkbox is unchecked. To test that, make sure it's still working fine. It's still working fine. And let's get back into it. Let's write the logic that outputs our side texture. All of these, move them down a little bit so we have some room to work. And we will do here the split again, but instead of the R and the B value, we're going to get the R and the G value. Create a vector 2. R and the G value will be this face and this face. So, going to do the same logic here, multiply by our scale. And of course, sample the 2D texture with the normal, with the UV set to this. Then we will plug that into our true. And now let's test the sides real quick before we move on to our condition. Let's go ahead and set that to true. This out, and that's looking good. So one thing we need to do is I accidentally set this to top texture. What I want to do is set that to our side texture. And then we will apply this wall, our side texture. Go back, it's looking good. That side and this side should be go. Let me grab one of my point light here so we can see the side. Yep, looking good. Let's just increase it so we can see. All right, so we got our top and the front and back face. Now, first, before we move on to the side faces, let's get our condition set up to determine which one of these routes it should take. The way we'll do that is get the normal vector, our object. And what we need to do, split it, and then check, see if the z-axis absolute is greater than 0.5. So we have all these nodes in. We should be able to plug this comparison into our branch. Now it should automatically tile the top and the front and back faces. Yep, we are looking good so far. We got our top and our front and back faces going, but we still have a bit of a problem with our side faces. So, the way we can fix that, simply with another conditional statement. So, out of here, you'll plug in another branch, and we will put this to false. And out of the branch, we again output that into our shader albedo. So let's first test it real quick, make sure false shows all the good stuff we want. Yep. Now let's go ahead and create our logic for building up our side UV. So we're going to do, grab this world position, go ahead and copy and paste it up here so we're not having to drag a new thing all the way up here because I don't like it when the flows go through things. So I'm just going to copy and paste it. I don't believe that has any impact on performance since you're just referencing a variable that already exists. I believe that's what it's doing and not necessarily running a function, right? Anyway, let's go ahead. Once you have your absolute world position again up here, we will want to split it this time. Since we've already covered our X and Z and our X and Y, we need Z and Y. So we'll grab Y right here, which is our green channel. Create a new vector 2. And our blue, plug that into the second value of our vector 2. And then we will multiply this by our scale. So we have to do, let me show you first what would happen if we simply follow the same logic as down here. So let's grab our side texture, our sampler, copy, paste it, move it up here. And let's just plug this into our UV. And let's go ahead and set our condition to true, so that way it automatically applies it to the object. What we have here is our side texture, but it's rotated. I'm not exactly sure why it's rotated, but I do know how to fix it. So what we need to do is simply rotate our vector here before it gets to the UV in our sampler. Move this out of the way, grab our output from our vector 2, and let's go ahead and multiply the scale here. think we could do it after we rotate it, but doesn't matter either way. Let's go ahead and multiply that, get it out of the way. Move all these back a little bit. Then what we need to do is use rotate function. We will grab a rotate on the UV2 because that's what we're working with right here. We will just rotate it by -90 degrees. We'll want to change that from radian to degrees. Plug this in. Save it. Now our texture should be facing the correct way. It should have the correct rotation to it. Now, the last step that we have to do, is write our condition that determines if this should be applied to a side face. So, go ahead and grab the normal vector of our object. Same logic that we're doing down here. This time, we're getting the absolute position of our z-axis, which we do by splitting, grabbing our blue color channel. Calculate the absolute on that. And then if that value is greater than 0.5, sorry, we want our red channel on that, not our blue channel. So if that value is greater than 0.5, that will determine if it should apply the side face to it. Now let's save it and see what we got. There we have it. We have our tileable material based on world position. Let me know if you guys liked this video. Go ahead and leave a like, leave a comment. Let me know what you plan on doing with this material. I'm excited and curious to see what you guys are working on. Thank you guys so much for watching. I'll see you all next episode.